For those of you that are playing along at home or watching this on the YouTube channel, here are the answers to the multiple choice question, okay? Now, when you get to the free response, that first free response question, so the cool thing about this is that this is how it shows you exactly how you can actually derive at this thermodynamic data. Because again, there's no delta H probes, there's no delta S probes, there's no delta G probes. So what you have is the Kp value, okay? Because you're talking about pressure, because it's the transition from liquid into bromine. And this would be an easy value to do. Literally, take liquid bromine, put it in a container, let some of it evaporate into a gas, and you measure the pressure when it reaches equilibrium. Okay? That's it. That's all you have to do. It's the easiest data in the world to collect. Monitor the temperature. You're going to see the pressure go up as a function of time as some of that bromine goes into a liquid from a gas. Okay? Or from a gas into a liquid. So, how you're going to do part A is that you're going to use that delta G equaling delta G naught plus RT times the natural log of Q. Now, here's the story. That's your generic equation. You're at equilibrium. So instead of Q, what are you going to use? K, because you're at equilibrium. So you know what the K value is. You have that number. Now, at equilibrium, what is delta G going to equal? Zero. Oh, so now we know delta G. You know the K value, that's that 0.281. You know the R, and you know the temperature. But again, I beg of you, the temperature is at 25. What are you going to do wrong?
Leave it at 25.
Leave it at 25. That has to be in Kelvin. So, if you do the math, you get delta G naught equaling 3.15 joules per kilogram degree Celsius. Now, let's talk about the significance of this. What's the sign of delta G?
Positive.
So is this a spontaneous reaction at 25 degrees Celsius? No. So what does that mean? How does bromine going to exist at room temperature?
A liquid.
A liquid, because you have a positive delta G. If this had been a negative delta G, bromine at room temperature would exist as a gas. Okay? Bromine exists as a liquid. And if that happened, the reaction I did yesterday, I made iodine, but let's say I used bromine. If this had been a spontaneous reaction, we would have made the bromine and then it would have automatically bubbled and turned into a gas. Okay. So, on B, you got 193 joules to vaporize 1 gram of bromine and 1 atmosphere to calculate delta H. So, here's the story. Is your delta H going to be a positive or negative value?
Positive.
Positive. Why?
Because you put in energy.
Yeah, you're boiling it. You're going to put energy into it. So, you got the 1 gram of bromine. What are you going to do with the grams of bromine? Change that into moles. So, you got that. So, you got the 190. So, let me give you a hint. So, there's your answer to A. Your answer to B, you're going to take the 193 joules and divide that by the moles, and you're going to get a delta H of 30.8 kilojoules per mole. Now, you got a positive delta H. Endothermic. Because you're putting energy into the system. Now, let's think this through. You got a positive delta H, and you got a positive delta G. But look at the reaction. What's going to be the sign of delta S? Positive. Why? We're changing it into a gas. We're changing it into a gas. So I got a positive delta H and a positive delta S, which means what in terms of temperature? It's temperature dependent above a certain point. Cool. So, then on C it says calculate your entropy, okay? Well, on that one, you're gonna go delta G equals delta H minus T delta S. What's the only thing you don't know? You know the temperature is at 25 degrees Celsius. You found delta G, you just found delta H, you're gonna solve for delta S. So if you do your delta S, you get 92.8 joules per mole Kelvin. Does that make sense that that's positive? If you look at the reaction.
Yes.
Yeah, because you're going from liquid into a gas. So this is a situation where we don't have delta S probes, but we can find it if we know what delta G and delta H are. Okay, so normal boiling of liquid, da 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 da. So on D, you're going to find that temperature. So at the critical temperature, what are you going to let delta G equal? When it's going to boil, what's delta G going to equal? 0. You're going to solve for the temperature. Now, think this through. Is that temperature going to be above or below 25 degrees Celsius? Above. That's why bromine is a at room temperature. So if you do the math on D, you're going to get 332 Kelvin. Okay? On the back side, just in the name of time, because I know the Southies have to go, if you do that back side, your answer to A, your delta H, is 8.16 kilojoules per mole. Your answer to B is your delta S, which is negative 181.8 joules per mole Kelvin. Now let's stop right there. So here's a reaction. Theoretically, you can take carbon and hydrogen gas and water to make ethyl alcohol. Okay, or ethanol, it's the same thing. You have a positive delta H and a negative delta S. Is it worth even trying this reaction?
No,
Why?
it's never gonna happen.
It's never going to be spontaneous. You have enthalpy working against it and you have entropy working against it. Okay? It's not going to happen. So oddly enough then, when you calculate delta G, what's going to be the sign of your delta G? 62.4 kilojoules per mole. Now, on E, you want to calculate the value of K. So that's the one where you're going to use that delta G equaling delta G naught plus RT times the natural log of K, and you solve for K. You set delta G equal to 0, and you get that K equal negative delta G naught over RT. Now, before you do any calculations at all, this is a non-spontaneous reaction. Is your K value going to be a big number or a small number? It's going to be a small number because it's not spontaneous. So, if you do your K value, you get 1.15 times 10 to the negative 11, which matches with the idea that this isn't spontaneous. That should all form a big web. Okay, so the last thing I've got, so here's a blank review, and then you're going to get the answer key to said review. All right, Kevin, shut down another camera.
For a quick question.
What?